All right, Ninja Warriors, welcome to yet another power packed session. And in today's session, we are going to cover the very first part of indefinite integration. If I'm audible and visible, do let me know in the chat box. Also, I can see comments pouring in. I can see Shravani, I can see Anime, I can see, okay, difficult name. All right, Gina. Hi, Gina. How are you? Okay. I can see Shrinu also. Guys, if you are having any doubts now, it will be very difficult for me to tell you the doubts in the session, right? So what you can do is you can just ping me on my Telegram channel, that is Namrata Jaisinghani. Okay, spelling check. Jaysi, correct? Jay. So this is Jaysi. This is t.me slash namrata.jaisinghani. Okay. All right. You can ping me there. I will let you know about the doubts and all. Okay. I can see Pragnesh. Good evening. Hi, Ramesh. How are you? Okay. All right. Ashwin, you're not fine. What happened? Hi, JJ. Hi, Subhash. Yes, best because I was not able to read your name. Okay. So today's session is going to be all about indefinite integration. Okay. For all of those who are new to the channel, new to the session, this is my brief introduction. My name is Namrata and I have over more than 10 years of teaching experience, both online and offline, and I have got various selection in various reputed colleges such as IITs, NITs and other reputed colleges as well. All right, I can see permutation and combination part 2. I already recorded that session. It might get uploaded by tomorrow. Okay, all right. Okay. Hi, good evening, Mr. Sal. Good evening, Rishita. Good evening, Raj Patel. How are you guys? Huh? Chalo. Let's start with the integration like content part. Where is the remote? Okay, all right. Yes. Okay. Let's start with the basics of integration. Okay. So integration, what is integration? Tell me in the chat box. Indefinite is basic part of definite integration, right, ma'am? No, we can't say that. Basically, indefinite integration and definite integration, these two are types of integration. But yes, if you understand indefinite integration nicely, then definite integration will be much more fun for you, right? So yes, you cannot completely skip indefinite integration and then jump on directly towards definite integration, right? So to understand the definite integration, you have to have a basic knowledge of indefinite integration. And to understand indefinite integration, you have to have basic knowledge of differentiation. Because if you are not aware about differentiation, then integration will be a little bit tough for you guys to understand. Okay. So yes, I can say that. So this is basically the starting of integral calculus, right? So we are just entering into the integral calculus part. Now you understand. If you are not paying attention to indefinite integration, you might lose out very good chunk of marks because you will not be able to solve definite integration, number 1. You will not be able to solve area under curve, number 2. And you will not be able to solve differential equations. So 3 chapters will be at stake. And by the way, all these 3 chapters are high weightage and important chapters which are dependent upon indefinite integration. So now you just understand that why indefinite integration is very important. Okay. All right. Yes. Okay. So you guys are already telling me integration is antiderivative. Okay. It is an antiderivative. So it's already written over here. Antiderivative, that means like the reverse process of differentiation. So differentiation means to break into many parts, and integration means to integrate, to sum up all the parts. Okay, that's the basic layman terms mein if I tell you the difference. Okay, so if f and g are continuous function such that g dash x, the derivative of g is f. So derivative of g is equals to f. That means integration of f will be equals to g. Integration of f will be equal to g, right? So again, derivative of g is coming out as f. That means integration of f will come out as g. So this is the basics of integration, I will say. Okay. And also, the expression which we are integrating over here. So we are integrating f of x over here. So we will call it as integrand. Integrand. So this is the term which JEE Main or NTA can use it to confuse you, right? So basically, if they are talking about find the integrand, that means what should be integrated to get the gx, just like that. Okay. Integration of f dash x is equals to fx. Very funny, isn't it? Is it? It is not funny. No, no, no. Where x is the variable of integration. So just like we were differentiating with respect to x, right? So we used to write dx in the denominator, if you can see. So in integration, what do? We write dx in the numerator. That means we are integrating with respect to the variable x. Okay. And c is the constant of integration. So what we do is, whenever we do indefinite integration, we always add constant of integration, especially for your school examination, because if you forget to add constant of integration, they will deduct your marks. Okay. So in the beginning, I would say, please make sure that you always add constant over here. Okay. All right. Now let us understand some basic formulas of integration, and then I will be gradually giving you some tips related to integration, some tips I would say related to how to tackle the huge and scary looking integration problems. Okay. But let's start with the very basic. Okay. Vishnu, I have already told you, na, if you were not listening, I have already recorded and given the recording, and it is getting stitched, and it will get uploaded by tomorrow, Vishnu, hai na? Okay. All right. Yes. Chalo. Now let us understand the integration of x raised to power n. The integration of x raised to power n. Tell me what is the integration of x raised to power n. So integration of x raised to power n will be x raised to power n plus 1 upon n plus 1. Right? So if you differentiate this, what will you get? You will get back to x raised to power n. Okay? Do it and let me know. Okay? Alright. And also please make sure that n should not be equal to minus 1. Because if n is minus 1, then what will happen? If n becomes minus 1, then this will become 1 upon x. And you know that whose derivative is 1 by x? Log x ka derivative is 1 by x, right? That means integration of 1 by x will be log x. Okay, that we will understand. Here the integration of e raised to power x is e raised to power x only. Okay. By the way, just tell me what is the derivative of e raised to power x? Ma'am, e raised to power x. So basically e raised to power x is a sigma male, which doesn't even care. Okay. What is happening, what is not happening. So e raised to power x, if you differentiate, e raised to power x. If you integrate, e raised to power x. Okay. All right. Okay. Now I already told you, the moment you put n is equals to minus n, it will become 1 upon x. The integration of this will be log of mod x. Log of mod x. Okay. Because if you differentiate now this, what will you get? You will get 1 upon x. Okay. All right. Yes. So reverse also it should actually, so integration is always a reverse process. So always think about the differentiation also. Okay. Now let's talk about a raised to power x. Integration of a raised to power x will be a raised to power x upon log of a. So understand here, the log of a is in the denominator. Okay. All right. Yes, Raj Patel. We will do everything, right? We are going through basics first and then we will level up. Okay. Now integration of cos x will be sin x. Now understand, this might create a lot of confusion in some people, because we get confused with integration and differentiation very often. So understand, the derivative of sin x is what? Cos x. So integration of cos x will be sin x. Okay. And similarly, derivative of cos x is what? Minus sin x, right? So that's why integration of sin x will be minus cos x. Okay. So in the differentiation, what is happening? The derivative of cos x becomes minus sin x in derivative, right? Cos x will have negative sign, but it is a different thing altogether while doing integration. Okay, so sin x ka integration is minus cos x. That I will make you understand. Do not worry. We will solve problems, so you will be like remembering all the things. Don't worry. Okay. Now sec. Okay, so this is very important. So integration of sec square x is tan x. Very important. Okay. What does that mean? Do you remember the derivative of tan x? What was the derivative of tan x? So derivative of tan x is sec square x, right? Okay. Similarly, integration of cosec square is minus cot x. So I have already told you, whenever there is the negative sign will be there. Now, yes, this is important. Now tell me, derivative of sec x. Ma'am, sec x tan x. So that's why integration of sec x tan x will be sec x. Again, these two, this is also very important. Okay, alright. Now again that cosec cot x. So again is there, that's why negative sign is there. So integration of cosec cot is minus cosec. Okay, are you like are you able to understand the formulas? Are you able to remember the formulas? Just let me know. Okay, chalo, let's do one thing. Let's do some problems so that all the formulas get fit into your system. Okay, so 1 upon x root x. ठीक है मैम. तो मैम it will be x 1 upon x raised to power half integration dx. Perfect. And it is going to be x raised to power minus 3 by 2 dx integral. It is going to be x raised to power. Now you know that x raised to power n ka integral is what? Tell me. Ma'am, x raised to power n plus 1 upon n plus 1 plus constant of integration. This is the formula. So this is going to be x raised to power minus 3 by 2 plus 1 upon minus 3 by 2 plus 1 plus constant. This is the final answer. Now minus 3 by 2 plus 1 will be x raised to power minus half upon minus half. So the plus constant. So this is going to be finally equal to 1 upon root x, because x raised to power minus half is 1 upon root x. This is minus of 2 because this 2 will go up plus constant. So this is the final answer. Let me know. Yes. Okay, so Raghavendra is saying minus 2x ki power minus 1 by 52. Why are you saying 50 by 52? Okay. All right. Cool. Now let me know the answer of this problem. Cos square x by 2 minus sin square x by 2. Okay. Okay. So first of all, now ninja tip of the day. Ninja tip of the day. Integration tip. By the way, this is an integration. Okay. So ninja tip says that never rush in integrating. In integration, never rush. Okay. So simplify first. Simplify and then integrate. Okay. Integration will be the last step. And same thing I mentioned while teaching you differentiation, right? Okay. Simplify and then integrate. Okay. Okay. So first of all, simplification. Do you remember the formula cos square x by 2 minus sin square x by 2? Ninja tip. simplify and then integrate. Okay. All right. Cos square x by 2 minus sin square x by 2. So cos square theta minus sin square theta is cos 2 theta. So this will be cos x. So integration of cos x is what? Sin x plus c. Okay. Easy peasy. Very easy question, right? Okay. All right. Okay. So now one integration by substitution. Now let's understand one technique which is integration by substitution. This is a highly and widely used method in the whole integration. So you will be loving the method of substitution, and method of substitution is something which will be frequently used. Throughout integration, you are going to substitute this, substitute that, substitute this, substitute that. So substitution is something which plays a major role in your overall integration. Okay. All right. So I is equals to integral of f of gx and g dash x dx. So what we are going to do is, first of all, I'm gonna put gx is equals to t. Let's put gx is equals to t. If gx is t, now differentiate both the sides. No, by parts, abhi nahi, right now nahi. Substitution is different, by parts is different. Okay. So yes, put gx is equals to t. Now differentiate both the sides with respect to x here and with respect to t here. So this will become g dash x dx on the left hand side, right hand side will be dt. Okay, so g dash x dx, if you observe, this will become dt. Okay, and this gx will be replaced by t. So the overall integration, if you observe, right now it is in form of x, right now it is with respect to x, and now it is become with respect to t. So f of t dt. Can you see? So integration of f of t will be the final. Okay. Yes. Clear? Chalo. So shall we do some problems based on integration of substitution? Are we substitution ready? Huh? So the very first thing in integration is I want to make you substitution ready always. Chalo, let's do. Let's understand that how many of you are able to do it. How many of you are able to do it? Huh? Chalo, try this question. Tell me. Tell me the answer in the chat box. Okay, while you do it and let me know, can you just spare me like less than 10 seconds? I'll come back because I just want to have some like water. So let me just bring water for myself. Chalo, let's see. You guys are saying B, B, B. Chalo, let's see. So again, log x ko I'm gonna put log x is equals to t. है ना? So in the beginning, sometimes you will feel that, ma'am, how are you thinking that this should be substituted as t? How are you able to think? So do not worry. What you can do is there are only two things. Can you see log x, x, 1 by x? Actually, three things. Three options. You only have three options. What other option you have? Nothing, na? It's the expression is very small. So hit and trial. Do hit and trial and do incorrect thing, then reject it, then do another, put another is equals to another expression equals to t. Just understand that what is working for you. Okay. All right. This is how you will learn. And then A few questions later, you will be like, now I am able to see this should be put t so that I get rest of the thing is dt. Okay? Log x equals to t. Now tell me 1 upon x dx, differentiating both the sides, will be equals to dt. Right? So this is going to be integral will be what? Tell me. So ma'am, integration of log x is t square and 1 upon x dx will become dt. Right? So t square ka integration, so you can write t cube by 3 plus constant. Now what is t? Come back. And now back to the log x thing. So log of x ka whole cube upon 3 plus c. So you guys are absolutely right. B is absolutely right. Okay. Clear? Chalo. Let's see. Next, if you're not able to understand that, ma'am, we still don't understand what to put t. No issues. Okay? Let's do one more question. Now just tell me. What will you put t? Now tell me. Okay. So x cube sine x raised to power 4. Correct? So now this time what I'm going to do is I'm going to put x raised to power 4 is equals to t. So that 4x cube dx will be equals to dt. Correct? So x cube multiply dx will be dt by 4. So finally your integration will become what? Tell me. So sine x raised to power 4. So sine x raised to power 4 is your t. Correct? X cube dx will be replaced by dt upon 4. Integration of sine t minus cos t, right? Minus cos t upon 4 plus c. If you replace t, minus cos of x raised to power 4 by 4 plus constant, which is matching with again option B. All right. Again B, again B. Cool. Perfect. Perfect. Okay. So the basic problems on substitution you have understood, right? Okay. Now, some more formulas. Are we ready for some more formulas? Be prepared. Why integration is considered as one of the toughest chapter. Let me tell you, it is actually not that tough. It's just that ki integration mein it tests both the things, memory also and I would say yes, logic also. Memory and logic this chapter tests. That's why there are very less people who are very confident about integration. Okay, so just understand, keep your memory very sharp and keep your logic also on point. Then you are like, okay, done. Integration, you are gone. Okay. Okay. Yes. Chal. Now, one more formula of integration. Integration of tan x is log of sec x. Okay. So, let us have a small proof over here. So, what we will do is, tan x ko let's write sin x upon cos x dx. Can I do that? And now what I'm going to do is, I'm going to put cos x equals to t. Put cos x equals to t. So, what will happen then? Tell me. If cos x is t, so if you differentiate, minus sin x dx will be equals to dt. Okay, all right. That means now your this integration, if I talk about now, sin x dx will become minus dt and cos x will become t. Now one student, ProCuber, you were asking this, right? This is your answer, okay? So this is actually minus 1 by t dt. So integration will be what? Minus log of mod of t plus constant, right? And if you solve this, this is minus log of t. What is t? Cos x. Cos x mod plus c. Now one more last thing. Now the moment you put this, this is minus 1. This minus 1 will be going on the power of cos x. Cos x power minus 1 is 1 by cos x, which is sec x, right? So this is going to be minus log, not minus, plus log mod of sec x plus constant. So this is the final. So integration of tan x is what? Tell me. Okay, Kritik. Got it, got it. So this is your answer. Okay. Now similar, integration of tan x is log of sec x. Mod, right? Mod is already there. Integration of cot x. Integration of cot x is log of mod of sin x. Okay. So साथ में you have to remember it. Okay. You have to remember it. ठीक है. Integration of cot x. Now the third formula, integration of sec x. Now integration of sec x is a little bit different. Integration of sec x is log of mod of sec x plus tan x, or you can say log of mod of sec tan of pi by 4 plus x by 2. है ना? Understand what is happening. So this proof is given in NCERT. And I to find this integration of sec x, specially prove that you can have it in your board examination also, because this is something which is a little bit trickier to prove, right? So now sec x. So let's do a little proof. So to find out the integration of sec x, so what we need to do is, I'm gonna multiply and divide it with sec x plus tan x and sec x plus tan x again. Okay, integration dx. Understood? What did I do? To integrate this, I have multiplied and divided sec x plus tan x and sec x plus tan x, ऊपर नीचे, है ना? In numerator, denominator. Now multiply. The moment you multiply, tell me what will you get? So ma'am, you are going to get sec square x plus sec x tan x. Okay, and we are having sec x plus tan x. Remember this, you have to multiply and divide. Otherwise, how will you integrate? Okay. Now, what will you do is, sec x plus tan x, you have to put t. Put sec x plus tan x equal to t. Now tell me, differentiation of sec x will be, ma'am, sec x tan x, correct? Differentiation of tan x, sec square x dx will be equal to dt. Did it ring the bell? Did it strike? Did it clicked? Just tell me. Did it clicked? What just happened? The moment you put denominator is equals to t, if this you put is equals to t, automatically if you differentiate both the sides, the numerator becomes dt. So it is actually becoming dt by t, which is log of mod of t plus constant. Now you just put the value of t, which is sec x plus tan x. So you've got this, right? You've got this, right? So this, correct? Okay, all right. Also, so this is going to be log of mod of sec x plus tan x plus constant, correct? Now just one more thing I would like to let you know, because these type of problems are very popular in JEE Advanced, because in multi-select question, they give you find the answer of this, right? So you should know, you should be aware that these two are one and same thing, okay? All right, yes, so sec x plus tan x. Now sec x will be 1 upon cos x and this is sin x upon cos x, correct? So this is 1 plus sin x upon cos x, correct? Now 1 plus sin x can be written down as, 1 plus sin x can be written down as cos x by 2 plus sin x by 2 whole square, correct? Upon cos x can be written down as cos square x by 2 minus sin square x by 2, Correct or not? Yes. Now, cos x by 2 plus sin x by 2 whole square, and this is a square minus b square. So, this will be a plus b, a minus b. So, finally, one factor will get cancelled out. So, we are going to left with this. And if I divide by cos x by 2 in both numerator and denominator, what will you get? Tell me. So, 1 plus tan x by 2 whole upon 1 minus tan x by 2. And this is actually tan of pi by 4 plus x by 2. Right? So, basically, sec x plus tan x can be written down as tan pi by 4 plus x by 2. Yes? Okay. Clear? Alright. So, integral of sec x is what? Ma'am, log of mod of sec plus 10 or log of mod of tan 45 plus x by 2. Okay. Now, similarly, integration of sec x is right here. Now, integration of cosec x, we can do it in a similar manner. I am not giving you proof right now. It's your job. Okay. So, I'm just giving you the direct formula. Integration of cosec x will be log of cosec x minus cot x. So, in this case, what will you multiply, divide in the very first step to integrate it? You will multiply and divide this factor, which is cosec minus cot, and then put the denominator equals to t, so that numerator will become dt. So, this is log of mod of cosec minus cot. And also, if you are going to solve this, right, also, this is also having another thing. So, you know that cosec minus cot and cosec plus cot, these two are in reciprocal relationship, right? These two are in reciprocal relationship. That's why these two can be written. Or the third thing is log of mod of tan x by 2, that can be proved. Okay. So, if you expand it, solve it, use submultiple angle formula, you are going to get this. So, 2 integration, done. Okay. All right. Okay. Now, there are some rules of integration. Let's get into that. Okay. Some rules of integration. So, the first rule clearly is the constant rule. So, suppose you know that integration, let me just tell you. Just tell me, 2 sin x dx integration, very basic rule, will be equals to 2. This constant will come out, sin x dx. And integration of sin x is minus cos x plus c. Right? Okay. Clear? Plus c. Again, if two functions are in summation, basically. Okay, so let me just take an example. Suppose x square plus 3x cube integration dx. If two quantities are in addition, then just integration of x square dx plus 3x cube integral dx. Right? This is x cube by 3 plus, if 3 is outside, integration of x cube will be x power 4 by 4 plus constant. Okay. Integration of sin x is what? Plus cos x, right? Sorry, my bad. No, minus cos x only, yaar. You guys are minus 2 cos x. Correct? Chalo, let's do some problems. Okay? First problem, you can see on your screen. It is 4x raised to power 5 plus root x. 4x raised to power 5 plus root x. Shall we do it? Okay. So, yes. 4x raised to power 5 integration, tell me. So, this is going to become, ma'am, integration of this will be 4x की power 6 upon 6 plus root x. Integration of root x, tell me. Integration of root x. X की power half plus 1 upon half plus 1 plus constant. Okay. So yes, this is how it is going to be. So now if you solve this, this is 3 by 2, this is 3 by 2. So 3 by 2 will become 2 by 3 plus constant of integration. This is the final result. Okay. Alright. So 4 by 6 is again 2 by 3. So 2 by 3 x raised to power 6 plus 2 by 3 x raised to power 2 by 3. Correct? Easy peasy. Alright. Yes. I guess I will have to remove one person. Okay. Andrew. Andrew has to go. Sorry. Andrew has to go. Andrew has to go. Hold on. Remove from the channel. Yes. Next question. Now the second question. Yes. Let's see how many of you are able to do this. Okay. So first of all, this will become what? 2 by 5 raised to power x minus 3 by 5 raised to power x. Okay. 2 by 5 raised to power x minus. Now you just tell me. Integration of a raised to power x is what? A raised to power x upon log a plus constant. Right? Yes. So this is going to become 2 by 5 raised to power x upon log of 2 by 5 minus. This is 3 by 5 raised to power x upon log of 3 by 5 plus constant of integration. Yes. So this is how it is going to become. Right? Clear? So this is the final answer. Clear? Perfect. Shall we move on quickly? Okay. One JEE main question. Okay. One JEE main question. Chalo. One JEE main question. It is a very old question. It was asked in IIT JEE 2007. Let's see. But you know, previous like very old questions have a tendency to get repeated. Okay. It is happening. Okay. It's a trend these days. So dx upon cos x plus root 3 sin x. Okay. But you will be saying, ma'am, you don't have taught this formula. So remember what ninja tip I gave you today in the chat box. One ninja tip I gave you today. What is that tip? Who is going to tell me? Who is going to tell me about the ninja tip? Simplification, right? Okay. So we will simplify it first. Cos x plus root 3 sin x. Don't you think this is of the form a sin x plus b cos x? Right? Okay. Yes. So cos x plus root 3 sin x. So basically what I'm going to do is dx upon cos x plus root 3 sin x integral. Alright. Yes. Now, a sin x plus b cos x can be formed in a formula by multiplying and dividing by square root of a square plus b square. Yes. So what I'm going to do is square root of a square plus b square. So square root of 1 plus 3. Square root of 1 plus 3 is 4. Square root 4 is 2. So I want 2 over here and I want 2 over here. Can I do that? Because I want to make a proper formula. Right? So now this is cos of 60 degree. That is cos pi by 3. And this will become sin pi by 3. So can you see what is this becoming? Cos A cos B plus sin A sin B. So cos A cos B plus sin A sin B is cos A minus B. So dx upon 2, this is going to be cos A minus B, that is pi by 3 minus x or x minus pi by 3, both will work. Both will work. Okay, both will work. So basically this is going to be sec x minus pi by 3, correct? and this is going to be 1 by 2 integral dx. Integration of sec x is what? Tell me. The integration of sec x is log of mod of sec x plus tan x, but it is very clear that right now we are not in that mood. Okay, we are going to put the another formula. So this is going to be log of tan pi by 4 plus x by 2. So that means x minus pi by 3 upon 2, bracket close, plus constant of integration. Okay, so this is going to be pi by 4 minus pi by 6. Pi by 4 minus pi by 6 is pi by 12. So tan pi by 12, and this is going to become plus x by 2 plus constant. This is log already there, mod is already there, 1 by 2 is also there. So just let me check out. I guess option A is absolutely right. Yes, option A. Okay. All right. Yes. Clear? Chalo. Now, the same integrals which we have studied, x raised to power n, e raised to power x, what will happen if x is converted into a form which is ax plus b? So suppose you are having e raised to power x ka integration, you all know this is e raised to power x, right? But what if you have to integrate e raised to power 2x plus 3? Then what will you do? So you are going to put that ax plus b is equals to t. So what we are going to do is we are going to put 2x plus 3 is equals to t. So 2x dx will become dt, right? Sorry, 2x, nahin, 2 dx will become dt. So now dx, understand what is happening. Dx will be dt by 2. That is one thing. And this is e raised to power t. So integration of e raised to power t is e raised to power t, half will be same, plus constant. So this is going to be e raised to power 2x plus 3 upon 2 plus constant. That's how it is done. Okay, that's how it is done. Okay, that's how it is done. So what we have, the shortcut, what is the shortcut? Every time you don't have to do it, okay? So you just remember e raised to power 2x plus 3 dx, shortcut direct. Okay, so ma'am, e raised to power anything, integration is the same. And you have to differentiate 2x plus 3 in the denominator plus constant. That's how it is done. Okay, so yes. Okay, now just understand ax plus b ki power n. So you remember x raised to power n integration is what? X raised to power n plus 1 upon n plus 1. So same, ax plus b raised to power n plus 1 upon n plus 1. But we are going to differentiate this internal thing in the denominator. So derivative of ax plus b will be a, which is there over here. Similar thing, 1 by 1. E raised to power ax plus b will be what? E raised to power ax plus b upon a plus constant. Okay. Alright. Then we have 1 upon ax plus b. Acha, 1 by x ka integration was log of mod of x. है ना? But the integration of this will be log of mod of ax plus b upon a. So just notice that everywhere same thing is happening, but just upon a. Upon a is appearing. Right? So here, because a is there, so bx plus c ka derivative is b. Right? Okay. There are some more. You can see integral of cos is sine. So cos ax plus b is sine ax plus b upon a. Right? And this is, can you see? Can you see? I just don't want to repeat the everything. Right? The integration of sec x tan x is what? Sec x. So integration of sec ax plus b tan ax plus b is sec ax plus b upon a. Okay. All right. Chalo. There are some more you can see. Same. It's just that same concept with different things. ठीक है, let's do some problems on this. Are we ready for the problems? Integral of 2 raised to power 3x plus 4 minus tan x by 4. ठीक है, so integral of 2 raised to power 3x plus 4, what will be the integral? Tell me. Yes, so it is going to be 2 raised to power 3x plus 4 upon log of 2, correct? Upon log of 2. Now please do not forget to differentiate 3x plus 4 in the denominator minus integral of tan is what? Log of sec x. Integration is tan is what? Log of sec x. So integration of tan x by 4 is log of mod of sec of x by 4. Let's not forget to differentiate this over here plus c. So finally it is going to be 3 raised to power x plus 4 upon 3 log of 2 minus 4 log of mod sec x by 4 mod close plus constant. ठीक है, प्लस कांस्टेंट. ठीक है, clear, perfect. So this is the final answer as you can see. Okay, all right, clear. चलो, are we ready for next problem? ठीक है, now sin square x. But sin square x integration we don't know. We know only the integration of sin x. So remember the ninja tip. If you don't know integration of sin square x, just simplify, change the form. Okay. So sin square x now, can I write sin square x? I have taught you in trigonometric gold formula. So sin square x is equals to 1 minus cos 2x upon 2, and cos square x will be 1 plus cos 2x by 2. Okay. So both ways. Now you have to convert. ठीक है. Sin square x will be what? 1 minus cos 2x upon 2 integral dx. Now integrate. X upon 2. Integral of cos x is what? Minus sin x. So integral of cos 2x will be minus sin 2x. 1, 2 is already there. Understand. Please do not ignore this. 2x. Now you have to differentiate 2x over here. So one more 2 will be here, and that's about it. This is your final answer. You can see. Integration of cos x is what? Minus, sorry, it is same na? Haan. ठीक है. Integration of cos x is what? Sin x, right? Integration of cos x is what? Sin x, correct? Okay. Yes, definitely mystery. Flashcards are very good and it cover all the formulae and shortcuts. No, only formulae. I mean, what are the shortcuts? Chalo, cos cube x. How will you do that? So cos cube के लिए remember that formula cos 3x. How many of you remember that formula? Cos 3x is what? 4 cos cube x minus 3 cos x. Okay. So from here, let us calculate the value of cos cube x quickly. So this is going to be cos 3x plus 3 cos x upon 4 integral dx. Correct? Now integrate. Integration of cos is what? Ma'am, sin. So sin 3x upon 3 4s are 12 plus integration of 3 by 4. This is again sin x plus constant. Done. Done. Clear? Yes? Clear? Shall we move on to easy questions? Both are easy. Now next question. So again, can you see simplification? Integration requires majority of the time it requires simplification. ठीक है? All right. Yes. Chalo. Next question. Cos x sin 3x. Again, we do not have a direct formula to integrate product of cos and sin. But we do have a formula in trigonometry which is 2 cos A sin B. 2 cos A sin B is what? Sin A plus B minus sin A minus B. So let us understand. So this is going to be, so 2 by 2. So 1 by 2 sin A plus B. So sin 4x minus sin A minus B. So this is going to be plus sin 2x. Correct? Integral dx. Now it's very easy. Integral of sine is what? Minus cos. So 1 by 2 minus cos 4x upon 4 minus cos 2x upon 2 plus constant is our final answer. Okay? If you multiply, you are going to get this. Clear? Perfect. Any doubts? Any confusion? One more question. Are we one more question ready? Chalo. Let's do this question. Again, dx upon root 2x plus 3 minus root 2x plus 2. So again, simplification. This demands rationalization. So rationalize it right away. Okay, so this is going to be dx upon root of 2x plus 3 minus root of 2x plus 2. Correct? And rationalize. So square root of 2x plus 3 plus square root of 2x plus 2. And this is going to be square root of 2x plus 3 plus square root of 2x plus 2. Now, this is going to be square root 2x plus 3 plus square root 2x plus 2. And this is a plus b, a minus b. So a square minus b square. So 2x cancel, 3 minus 2, 1. That means the denominator becomes 1. Okay? Denominator becomes 1. Now we just have this. Integration of 2x plus 3 raised to power half plus integration of 2x plus 2 raised to power half dx. One by one we have to differentiate both the terms because denominator is anyway 1, right? So this is going to become 2x plus 3 raised to power half plus 1 is 3 by 2 and this is 3 by 2. Again same thing, but hold on, please do not forget. Now you have to differentiate 2x plus 3, so you will have one more 2 over here, okay? Plus again 2x plus 2 is there, power is 3 by 2 and this is going to be 3 by 2. And now one more 2 is already there. So plus constant of integration. So finally 2 cancel. So yes, final answer will be what? This is the final answer. 2 cancel out. So this will be the final answer. Yes. Okay. Kamex is saying, ma'am, in Vedantu JEE Sankalp batch, I have a doubt in this lesson. Sankalp batch, okay. Yes, definitely you can follow. है ना? ठीक है? Got it? Clear? Now, we are having one question from JEE Main 2017 and trust me, I used to teach this question. I used to take this question since, so I am teaching since very long, right? So I was taking this question before 2017. Every year I used to take this question. And then after some years, this question came in JEE Main. Okay, this is very good question. I love this question. And only those people who are having very good observation skills now, only they will be able to decode this question. Okay, all right. Yes. Yes, hi Navdeep. Thank you. Good evening. So first of all, multiply. I will make sure that you understand this. The concept will get clicked. This is a very good question, okay? So 1 plus 2 cot x cosec x plus 2 cot square x integral dx. Obviously, ninja tip of the day. Think about simplification. So simplification of this expression means what? To get rid of the square root, right? To get rid of the square root. So we need to get rid of this square root. How will you get rid of the square root? Just tell me. by making the expression a perfect square, right? So we want this expression to become a perfect square. Now we can clearly see that perfect square means what? A plus b whole square, because we can see that this is 2, this is cot x, this is cosec x. 2ab, right? So 2ab is already here. What I want is cot square and cosec square. How will I get it? Because I have cot square. Cot square I have. Okay? So let's do one thing. Let's just write like this. 1 cot square I am taking. 1, no. Conversion will not help. Tell me. A plus b whole square is what? A square plus b square plus 2ab. Can you see 2ab over here? 2 cot x cosec x is already there. Now what you need is 1 cot square you need and 1 cosec square you need. Okay. So yes, 2 cot x cosec x I am keeping it here, plus cot square x I already have, plus 1 more cot square x is already you have, so 1 plus cot square x. Can you feel it? Now, how many of you understood this? What is happening? 1 plus cot square x can be written down as cosec square x plus 2 cot x cosec x plus cot square x. Now, can you see? Did it click? Did it click, my dear students? Yes. So, basically, this is a square plus 2ab plus b square, which is going to be a plus b whole square. So, integration of root of cot x plus cosec x whole square. Now, this question is done. Now, this question is done, right? So, this is going to become cot x plus cosec x integral and dx. That's it. Okay. All right. Now, integration of cot x and integration of cosec x. That's we need to do. Okay. So, cot x. Now, you convert. Cot x is what? Sin x upon cos x. This is your cot x. Cosec x is what? 1 upon sin x. Correct or not? Yes. Dx. Sorry, cot x gone wrong. This is cos x by sin x. Now it's fine. So 1 plus cos x upon sin x integration dx. So this is going to become 2 cos square x by 2 upon 2 sin x by 2 cos x by 2. So remember, understand what we are doing. We are still simplifying. Integration though we have not taken into account till now, right? Cos x by 2. So this is going to be cot x by 2. Cot x by 2. Now tell me the integration of cot x by 2. Integration of cot x by 2. So integral of cot x is log of mod of sin x. So this is going to be log of mod of sin x by 2 and upon 1 by 2 plus constant. So 2 log sin x by 2. 2 log sin x by 2, option A is absolutely correct. Have a look and let me know. ठीक है? All right. Chalo. Let's move on to the next problem. Chalo, let's see what's there in our next plate. Okay, so this x cube upon x minus 1 is something which we need to integrate. Okay, all right. So understand what is happening. Right now we can't integrate. So we have to do some manipulation. Okay, we have to do some manipulation. Now understand one thing. X cube so is fine, right? But upon x minus 1 is not fine. I want something in numerator so that I can factorize it, right? X cube upon x minus 1. I want something in the numerator to factorize it, okay? So what I'm going to do is x cube minus 1 plus 1. Can I do that? Some manipulation skills will be required. Why I'm trying to do that? Because otherwise what I don't have any other option. Okay, right now, so in this state, so we cannot integrate, right? Yes, so x cube now separate. X cube minus 1 cube together and 1 upon x minus 1 separate. Now a cube minus b cube. A cube minus b cube is a minus b. A square plus ab plus b square upon x minus 1. This will get cancelled out. So now integration of just x square plus x plus 1 will be easier for us. And now this 1 upon x minus 1. So this is actually 1 upon ax plus b wala form. Integration of 1 by x is what? Log x. So integration of this will be log of x minus 1 plus constant will also be there. We need to integrate this. So this is x cube by 3 plus x square by 2 plus x plus log of mod of x minus 1 plus c. This is your final answer. Okay. Yes. Clear? Chalo. So this is how it is done. Adding 1 and subtracting 1. Now next question. Chalo. Let's see how many of you are able to answer this. Next question on your screen. While you do this question, shall I like come back in 10 more seconds because this studio is very hot. I'm sweating a lot. Today is Sunday. I don't know, some like AC is not working. So I am having sweat all over my face and I need to drink some water. Okay, but till the time you do this problem, I'll be back in less than 10 seconds by. Let's see. तो substitution का game है boss. Substitution का game is on over here. So you know the tan inverse x, right? So let's put m tan inverse x is equals to t. Or you can put directly just tan inverse x equals to t. Now the moment you put tan inverse x equals to t, the derivative of this will be 1 upon 1 plus x square dx is equals to dt. So that means this will become dt. Integration of mt dt. So integration of mt is integration of mt upon m plus constant. Now replace t. T is what? Tan inverse x upon m plus constant. Okay. So e की power tan inverse x upon m. Option B, absolutely right. M also you can put, but you can simply put tan inverse x also. Okay. All right. Clear? Chalo. Now next problem. I'll give you some time. Tell me how it is done. 5 raised to power 5 raised to power 5 raised to power x. Okay. Multiply 5 raised to power 5 raised to power x, multiply 5 raised to power x dx. Now what to put t? This or this? So you can start with any. Okay. If you want, you can start with this also, but let me tell you, 5 raised to power 5 raised to power 5 raised to power x. If you put this as t, then what will happen? Then understand. So derivative of a raised to power x is what? So ma'am, derivative of a raised to power x is a raised to power x. So 5 raised to power 5 raised to power 5 raised to power x. Now, chain rule. So you have actually, so basically this is a sum variable. 5 raised to power this variable is equals to t. So 5 raised to power any variable derivative. Basically a raised to power x ka derivative is what? A raised to power x log a derivative. So this is going to be log of 5. Okay. Now differentiate this. So this is going to become by chain rule. So ma'am, 5 raised to power 5 raised to power x, one more time log 5. Now differentiate 5 raised to power x. So this is going to be 5 raised to power x and one more log 5. Now differentiate x. So that is going to be 1 or dx, that is going to be dt. Now tell me what is happening. So basically this 3 terms into dx is becoming dt upon log of 5 ka whole cube integral. So this is coming what? This is the constant. So t upon log 5 ka cube plus c. What is t? Same thing, which is 555x upon log of 5 ka cube plus constant. Okay. So this is going to become option B. Option B. Okay. Option B is absolutely right. One more question ready? One more question? ठीक है? चलो. Let's do one more question. Find the value of integral of tan cube 2x into sec 2x. How will we do it? ठीक है? That's C क्या? Oops. Not B, but C. Thank you so much, Gina. Thank you. है ना? Correction. Option C was the correct answer. चलो, let's do this question now. ठीक है? So what we are going to do is find the value of tan cube 2x sec 2x, correct? Now in this question, what I'm going to do is tan cube 2x, I'm going to write it as tan square 2x, tan 2x sec 2x dx. Correct? Okay. And this tan square x will be, now because we are simplifying, we are manipulating, right? This is going to become sec square 2x minus 1 and this is tan 2x sec 2x dx. Correct? Now multiply. Sec square 2x is already there. Tan 2x sec 2x minus tan 2x sec 2x dx. To solve this, what I'm going to do is putting sec 2x is equals to t. Okay. To solve this, what I'm going to do is sec 2x becomes t. So in derivative of sec x is what? Sec x tan x. So this is sec 2x tan 2x into 2 also will be there. 2 into 2. Dx will become dt. Right? So this thing, if I talk about integral, so this is t. T square tan 2x sec 2x dx. Tan 2x sec 2x dx will be dt by 2. Integral minus integration of tan 2x sec 2x is what? Tell me integration of this. So this is going to become what? Again, this is dt by 2. Basically, we don't have to multiply. Just remove this step. We don't have to multiply. Yes. What we need to do is just put sec 2x is t. So this is your t. Sec 2x is equals to t. So this is going to lead us with what? 2 sec 2x tan 2x dx will become dt. So this is t square minus 1 and this is dt by 2 integral. That's it. So 1 by 2 t cube by 3 minus t plus constant. Okay. All right. And. Yes. Now you put t sec. Okay. So this is option C. Yes. Option C again. Absolutely right. Correct. Option C. Absolutely right. Okay. Hi Gauri. How are you? Yes. Clear? Shall we move on to the next problem? Okay. Alright. So this was asked in JEE Main 2019. JEE Main 2019. Okay. So again, integral of this is what we are looking for. Okay. So this is a very big expression, but trust me, the moment you start substituting now, everything will be very easy. So substitute x square minus 1 equals to t, so that 2x dx will become dt. So this x multiplied by dx, x dx will become what? Dt by 2, right? So this is going to become dt by 2 and square root is already there. So 2 sine t minus sine 2t upon 2 sine t again plus sine 2t. Correct? Yes. Dt by 2, let me just write near only. Dt by 2. Okay. Now, sine 2t I can expand. So 2 sine t minus 2 sine t cos t whole upon 2 sine t plus 2 sine t cos t. So just tell me, 2 is getting cancelled out? Yes, ma'am. Sine t is also getting cancelled out? Yes, ma'am. And this is dt by 2. So this is actually becoming 1 by 2 integral of, this is 1 minus cos t upon 1 plus cos t. 1 minus cos t upon 1 plus cos t dt. So now finally 1 minus cos theta is what? 2 sine square theta by 2. So this is going to become 2 sine square t and this is going t by 2. 2 cos square t by 2. 2 cancel. This is going to be tan square ka root. Let's not forget half and integral. Right? So this is what? Sine by cos. So half tan t by 2. So we need to find the integral of half integral of tan t by 2 dt. Integration of tan is what? Integration of tan is what? Integration of tan is what? Log of mod of sec x. So this is half log of mod of sec t by 2 upon t by 2 ka 1 by 2 plus constant. Half getting cancelled out. T is x square minus 1 by 2. So now, yes, option A seems to be the correct one, right? Option A seems to be the correct one. Okay. Option B? No. Option B is incorrect. Now, half is getting cancelled out. So this is t by 2. Sec t by 2. T is what? X square minus 1. Sec x square minus 1 by 2. So sec. Oops. Okay. Hold on. The square. Sorry. Square is already there. No. So this is Actually, D option is correct, right? D is correct. Can you see D is correct? D is correct. Yes, Sanjay. Yes, yes, yes. Okay. All right. Yes, Abdullah. So D is the correct one. Next question ready? Next question ready? Chalo. JEE Main April 2019. Okay. The integral 2x cube minus 1 upon x raised to power 4 plus 4. Okay. All right. So this is a little bit tricky question, huh? You have to do some trick over here. So first of all, x raised to power 4 plus x. Let's do one thing. Let's try putting this is equals to t, so that now if you just integrate or differentiate, the 4x cube plus 1 dx becomes dt. Let's put x raised to power 4 plus x is equals to t. Right? So when x raised to power 4 plus x becomes t, 4x cube plus 1 dx becomes dt. Alright? Clear? So now, what we are going to do is this, in the numerator, we are going to create 4x plus 1. Let's do that. Okay. So, integral of 4x cube plus 1 I have created, but I have to subtract also something, so that the overall result is 2x cube minus 1. So, first of all, 4x cube is there. So, we have to remove 2x cube. So, the overall final answer, final numerator is the adjusted. It should be 2x cube. So, 4x cube minus 2x cube is what? 2x cube. Now, plus 1 is already there. Plus 1 is already there. So, I need to actually add 2 in it. Yes. So, that 1 minus 2 will become minus 1. Now, it's fine. Upon x raised to power 4 plus x upon x raised to power 4 plus x. Okay? This is dx. That's it. This is also dx. Okay? So now what you have done for this left hand side, if you put this is equals to t, this becomes dt. So this is becoming integral dt by t. Right? Now here, if you take 2 common and if you take x common, so minus 2 upon x. If I take 2 common from numerator x cube plus 1, and here also x cube plus 1 dx, so sorted, this is gone. So minus 2 by x dx. Now this is actually coming out as log of mod of t minus 2 log of mod of x plus constant. Log of mod of t x raised to power 4 plus x minus 2 log of mod of x plus c. Obviously, this 2 will go up. So, this is x raised to power 4 plus x upon x square. Upon x square. Okay, so x cube. So, this is going to be log of plus c. Log of x, if I take common, x cube plus 1 upon x plus x cube plus 1 upon x plus c. Now, can you see option C is absolutely right? Yes? Clear? Option C right? Okay? Chalo. Let's do one thing. Let's take a quick 10 minutes break. है ना? So let's meet at 7:35 पे मिलते हैं. Let's meet at 7:35. ठीक है? Okay? All right, come back, come back, come back, come back, come back. We are back. Okay, all right. So, yes, now there will be some problems where you will need substitution, basically trigonometric substitution. Okay, so this type of thing we have already studied in which chapter? Inverse trigonometric functions. Inverse trigonometric function, remember I told you that, okay, if you look, if the expression is like this, basically if the expression looks like a square plus x square, right, then you have to substitute a tan theta or a cot theta. Now you must be wondering, ma'am, do we have to remember, do we have to cram this, do we have to rot it? No. Just understand, a square plus x square, you have 6 trigonometric ratios: sine, cos, tan, cosec, sec, cot. And you know identities, the basic class 10 identities also: sine square plus cos square, 1 plus tan square kya hota hai, sec square, 1 plus cot square is cosec square, right? So accordingly you have to think a square plus x square. Now just tell me, if you put x is equals to a sine theta, will it make some formula? No, it will become 1 plus sine square theta. There is no such formula. But if you put tan or cot, so 1 plus tan square and 1 plus cot square is a formula. That's why the moment you see a square plus x square, remember tan and cot. The moment you see a square minus x square, now this time sine and cos, because 1 minus sine square theta, right? The moment you see x square minus a square, right, and especially when they are inside the square root, now then you see that you cannot just repeat, like you cannot interchange both of them just by taking minus sign common. Then what will you do? Now this time sec and cosec, and the last thing which is very important, the moment you see both the things, a plus x and a minus x, remember cos theta. Why? Because you know that square root of, okay, you know that 1 minus cos 2 theta is also a formula, and 1 plus cos 2 theta is also a formula. So this is 2 sine square theta and this is 2 cos square theta, correct? So if you see both the terms, both a plus x and a minus x in a single expression, then you are going to put a cos 2 theta. Okay, all right, clear? Chalo, let's do some problems. Okay, so this is the very first integral, that this formula you have to remember, which is what? Dx upon, so basically integral of 1 upon root a square minus x square. Remember that 1 upon square root 1 minus x square ka integral is what? Sine inverse x, because in inverse trigonometric function we have studied derivative of sine inverse x is 1 upon square root 1 minus x square, right? So this is going to become this. Okay, remember in sine inverse formula, this is a major mistake. Many students commit this mistake. There is no 1 by a over here. 1 by a is missing over here, right? That it's not 1 upon a sine inverse x by a. No, it's just sine inverse x by a, right? So the moment, now how to solve it, how to get this? So the moment you see a square minus x square, put x equals to a sine theta. The moment you put x equals to a sine theta, to dx will be what? A cos theta d theta. Correct? Now integration of dx will be a cos theta d theta upon square root of a square minus a square sine square theta. If you take a square common, then a will get cancelled out. So basically a by a. Square root 1 minus sine square a is cos square theta. This is again cos theta d theta upon integral. Cos theta cancels, so this a cancels, so this is actually coming out as d theta. Integral of d theta is theta plus c. What is theta? From here, what is theta? So x upon a is sine theta. So theta will be equal to sine inverse x upon a plus constant. Okay, all right, clear? Any doubts in this? Any confusion? Perfect. Okay. So this is the formula that you have to remember. Next formula is, so substitution, you know, now I'll be just telling you the formula, okay. 1 upon x square plus a square is 1 by a tan inverse x by a. Remember, here there is no 1 by a, but here there is 1 by a. Please do not make this mistake, okay. Sin inverse mein there is no 1 by a, but tan inverse mein there is 1 by a, okay. So 1 upon x square plus a square will be 1 by a tan inverse x by a. And the same thing, can you see 1 upon mod x square root x square minus a square will be 1 upon a sec inverse x by a. ठीक है? Clear? Okay. All right. Now, let's solve some basic problems on this. 1 upon x square plus 5. Very obvious that this is going to be 1 upon x square plus root 5 square integral dx. Now you know the formula, right? That 1 upon x square plus a square is 1 upon a tan inverse x by a, correct? Plus constant c. So this is going to be 1 upon root 5 tan inverse x upon root 5 plus constant. This will be the final answer. Yes, 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 yes. Okay. Gina is asking why it is like this. Sine cannot have 1 by x where tan can have that. Gina, because if you solve this now, so what is happening? I have proved it also. Because there is square root, na? Involvement of square root is there. So that's why this is square root of a square is getting formed. Square root of a square will become a. A is getting cancelled out here. But can you see, here there is no square root. So from the denominator, it will be a square. From the numerator, it will be a. A upon a square will be 1 upon a. Right? So you do the proof. One proof I have already told you. Second proof you can do. Then you will understand why is it happening. Okay? Alright. Clear? Chalo. Hi Anushri. I'm absolutely fine. How are you? Now, so this is done. Now another question with a little bit manipulation over here. So 2 plus 5x square upon x square 1 plus x square. Okay. So clearly right now the expression is jumbled up. What we can do is we can try to factorize it. Okay. So this is going to become 2 plus, now 5x square can be written down as 2x square plus 3x square, so that this can be clubbed together, and over here it is 1 x square 1 plus x square dx. Perfect. Now separate it out. 2 1 plus x square upon x square 1 plus x square plus 3x square upon 1 plus x square integral dx. Correct? 1 plus x square 1 plus x square gone, 2 upon x square integral dx plus x square gone, 3 upon 1 plus x square dx. Now this is actually 2 ki x ki power minus 2. So now x ki power minus 2 integral will be plus 1 minus 2 plus 1 plus this is 3 tan inverse x plus constant. So this is going to become what? Minus 2 by x. Finally it will be what? Minus 2 upon x plus 3 tan inverse x plus constant of integration. Yes? Clear? Perfect. Okay, so that's how it is done. If it is clear, so shall we move on to some more formulas? Okay. So now we have another formula which is this. 1 upon a square plus 1 upon square root a square plus x square. Again, how will we do it? By putting x equals to tan theta. We can prove it. Okay. So this is going to be log of mod of copy paste. Can you see? This is the integral of 1 upon root a square plus x square is equals to log of mod of x plus root x square plus a square, right? So this is going to be like this. Now put x equals to tan theta. So you will get your answer. Integral of dx upon a square plus a square tan square theta ka root. A square can come out, so 1 by a. This is going to be dx upon square root 1 plus tan square. 1 plus tan square theta. 1 plus tan square theta is sec square theta. Sec square theta ka root is sec theta. So this is 1 upon a cos theta. Oops. dx nahi hona chahiye na. Sorry. And a dx will be gone. Now dx can be calculated from here. A tan theta ka derivative is sec square theta d theta. Okay. So this is sec square theta d theta. A is already there. So a sec square theta d theta. Correct? So this is what? Finally, it will become what? Just sec theta integral d theta. So sec theta integral is what? Tell me, do you remember today we have studied log of mod of tan x plus sec x or sec x plus tan x. So this is tan theta plus sec theta. So this is plus constant. So log of mod of, okay. Now tan theta, tell me, tan theta is x upon a plus sec theta. So from sec theta, can I calculate sec theta from here? Let's square. So x square is equals to a square tan square theta. Let's add a square both the sides. So it is going to be a square sec square theta. So it is actually becoming sec theta is what? Sec theta is square root x square plus a square upon a square plus c. Correct? Correct. Now can I write it this way? Log of mod of x plus square root x square plus a square, and this will be upon a. Whole upon a will be there, right? Root a square is a. So a is common denominator. So this is going to be minus log a, which will be adjusted in this constant. Okay. So finally it is log of mod x plus square root x square plus a square. This is how it is done. So this is a proof. But all you have to remember is not the whole proof, but the substitution, number 1, and the formula. Okay. Let us do some more. So this is the formula. 1 upon square root a square plus a square is log mod x plus copy paste root x square plus a square. Okay. Similarly, another formula 1 upon root x square minus a square will also be the same. Log mod x plus copy paste. Okay. Then we are having dx upon a square minus x square. Now this is something very, very important. This is important one. So this is going to become 1 upon 2a log of a plus x upon a minus x. Okay. So these are the formula, 3 formulas that you have to remember. Okay. All right. Clear? Yes, second part of permutation will be uploaded already. I have recorded, already given. They will just have to upload. Okay. Chalo. And this you don't have to remember it. Okay. Only remember this, because if you remember this, na, a square minus x square, then if in case the situation arises that x square minus a square you have to figure out. Okay. So you have to just take minus sign out and you put it over here. Okay. So 1 upon a square minus x square is 1 by 2a log of a plus x, a minus x. Okay. So let us focus on this. 1 upon square root x square plus 2 square. Very easy. We remember the formula. Right? We remember the formula log of mod of x plus copy paste plus copy paste plus copy paste. That's it. This is the final answer. Right? Okay. Chalo, next question on your screen. Let's understand this. Okay. So now e raised to power x minus 1 upon e raised to power 2x minus 1. Let's separate it. E raised to power x upon e raised to power 2x minus 1 ka root minus 1 upon e raised to power 2x minus 1 dx. Can I separate it like this? Okay, so what I'm going to do is I'm going to put e ki power x equal to t. If I put e ki power x equals to t, e ki power x dx will become dt, my dear students, right? So this e ki power x dx, so this will become dt upon square root of t square minus 1. So the first half is sorted. First half is sorted. This is actually of the type 1 upon square root x square minus a square, and this will be actually log of mod of t plus square root t square minus 1 mod close. This is done. What about this? What about this? So for this, what I'm going to do is I want e raised to power x in the numerator and denominator. So that I'm going to multiply and divide e raised to power x here, e raised to power x here. Now same, use the same substitution. E raised to power x dx will become dt and this will become t square root of t square minus 1. Do you remember? Do you remember? Do you remember this is directly what? Tell me. This is what? Sec inverse. So minus sec inverse t plus constant. Now plug in the values. Okay. So log of mod of t, that means e raised to power x plus e raised to power 2x minus 1 mod close minus sec inverse e raised to power x plus constant. That's your final answer. Okay. Okay. All right. Clear? Any doubts? Any confusion so far? Okay. So one last question we will do on substitution, and then we will talk about how to integrate a function where product of two different functions are involved, basically by parts, or you can say Eilert rule. Okay. So one last question we will do right here. X upon x raised to power 4 minus 1. How will we solve it? So it is very easy. X raised to power 4 minus 1, right? So x square can be put as t so that x dx will become dt by 2. X dx will become dt by 2. And this is going to be x square is t. So this is t square minus 1. Remember I told you that formula. 1 upon a square minus x square ka integration dx. Tell me. 1 upon 2a log of mod of a plus x upon a minus x plus constant. Okay, so here t square minus 1. So what I can do is take minus sign common. 2 is already outside. This is 1 square minus t square. Now minus 1 by 2 is outside, and this is going to be 1 upon 2 into 1 log of mod of 1 plus t upon 1 minus t plus constant. This minus sign, if you have to adjust, this minus sign can go over here. It will become minus. So you just have to take reciprocal. So 1 upon a log of t minus 1 upon t plus 1 can also be written. And the t is x square. So this is going to be 1 by 4 log of x square minus 1 upon x square plus 1 plus constant. Okay. This is the final result. Clear? 1 upon 4 log mod of x square minus 1 upon x square plus 1. Clear? Okay. So this was the last question on substitution. Now let's move ahead. Let's talk about by parts. Okay. That will be our last topic for today, and the rest, last topic as in it is obviously it is a very big topic. So after that, then it will be another session. Okay. All right. Chalo. Integration by parts. So again, if two functions are there and we have to integrate the product of two functions, So first of all, you have to identify there will be the first function and there will be a second function. Okay. So first and second function will be classified how? Okay. So choice of u and v will be classified how? Based on Eilert rule. Eilert rule. What is Eilert rule? What is Eilert rule? So first of all, identification let's learn. Eilert में I stands for inverse trigonometric function, L for logarithmic, A for algebraic. Algebraic means x, x square and all. Then trigonometry, then exponential. ठीक है? Okay. Alright. U dot V. Now, what is the formula? So suppose you have identified this is first function, this is second function. है ना? So what is the formula? Understand only once. Only once. You have only one chance. Do not come back, watch it again. No. Full focus. Just once you have to understand. Just once, and then you have to just solve problems. Okay? So now first, second. First function you have to keep constant. Integration of second function minus integration of derivative of first function and integration of second function again dx with respect to dx. Okay, so what is happening? So can you see in this first function is never ever integrated. In fact, first function is differentiated, but the second function, if you can see, the second function is integrated individually here and here. What does that mean? That second function should be that function whose integration you know. And first function should be that function whose integration maybe it is possible that you don't know. Right? So clearly, inverse trigonometric function, suppose sine inverse x. Sine inverse x, if you see, that will be your second function. Right? So the priority order is like this. Okay? So inverse trigonometric function will be your first function. First. Because why? Because first function you are not integrating. Right? Sine inverse x ka integration do you know? No ma'am. Then how can you like mark it as second function? Second function should always be that function whose integration you know. That's why this order is like that. Inverse trigonometry ka you don't know. So mark it first. Logarithm ka you don't know. So you mark it first. Algebraic ka you know. That's why the priority list is like that. Okay. If two functions are algebra, Anushri, then you have to apply another methods. Eilert rule is not applicable for every expression. Okay. So there are multiple techniques of integration. Integration by substitution. There are formulas also. है ना? So when everything is not working out for you, then you are coming to Eilert. Okay. So let's do one example and then understand. Okay. X tan inverse x. So now this is algebraic function. This is inverse trigonometric function. So this will be taken as first function. This will be taken as second function. Because we never ever know the integration of tan inverse x. We don't know it, right? We know the integration of x. That's why it will be taken as second. Okay. So priority should be inverse or logarithm. Then it is algebra, then trigonometry and then exponential. Okay. The first function ke liye it is there. Now, first and second, what is the formula? Just tell me. First function constant, integration of second minus integral of derivative of first, integral of second and overall integration of these two. ठीक है. First function constant, that means tan inverse constant. Integration of second means x square by 2. Integration of x is x square by 2 minus integral of first ka derivative. So first, where is first? First is tan inverse x. Derivative of this will be 1 upon 1 plus x square. Integral of second. So second, where is second? Again, integral of second, we have already done it, right? X square by 2. That's it. Now you have to only focus on this, the combine. So this is x square by 2. Tan inverse x. And this is minus 1 by 2. Now x square upon 1 plus x square is written. What will you do? You will add 1 and subtract 1. Okay. So it is going to be 1 minus 1 upon 1 plus x square. Now if you integrate, so this is x minus integral of this is tan inverse x. So basically 1 by 2 have taken common integration of x square upon 1 plus x square dx. That's what you need to figure out. And this integration is actually x minus tan inverse x. So final answer will be x square by 2 tan inverse x minus 1 by 2 and the same thing x minus tan inverse x. This is the final answer. Okay. So chalo, let's match it right away. X square by 2 tan inverse x is everywhere. This is wrong, obviously. Anna, between A and B. Now minus x by 2 is here and minus minus plus. So option A is clearly correct. Option A is absolutely correct. Okay. Next question. Chalo. Next question. X square sin x. X square sin x again. Eilert rule say inverse trigonometry is there? No, ma'am. Logarithm is there? No, ma'am. Algebra is there? Yes, ma'am. Mark it as first. Algebra will be marked as first. Then second is this. This is your second function. Okay. Chalo. So what is the formula? First function constant. Integration of sin x is minus cos x. Minus integral of derivative of first function. So derivative of first is 2x and integral of second is minus cos x dx. Okay. So this is going to become minus x square cos x minus minus plus 2 integral of x cos x dx. Now again we are stuck in the same situation right now. Okay, again we have to apply the second time by parts to solve this. Because there are two functions which are totally, absolutely different category function. One is algebra, one is trigonometry. In that case, you have to apply by parts for sure. So now, this will be your first and obviously this will be your second. Algebra and then trigonometry. So minus x square cos x plus twice. First function constant, integral of second is sin x minus integral of first ka derivative is 1 and second ka derivative is sin x dx. Perfect. Minus x square cos x plus 2x sin x plus, minus 2. Integral of sin x is what? Minus cos x. Plus cos x plus constant. Now tell me minus x square cos x is everywhere except B. Plus 2x sin x is everywhere except C. Then we are having, so which answer is correct? Tell me, option A clearly is matching. Option A is matching. A. Okay, clear? A is the correct option. A is absolutely correct. Now is the time for ninja tip. And a ninja technique. So ninja technique for x raised to power n sin x type of questions. So integration of x square sin x dx. Okay. So now x square is kept constant and you have to differentiate. Sin x. So that will give you minus cos x. Minus, this time you have to differentiate x square. So you will get 2x. And now you have to differentiate minus cos x again. Right? Minus cos x you have to differentiate again. So derivative of minus cos x is what? No. Sorry. Hold on. Yes, perfect timing from फिर से again. So ninja technique for these type of problems. So what you need to do is first function x square is constant. Integration of sin x you have to do. That is going to be minus cos x. Correct? Minus cos x. Minus cos x. Then negative sign will be applicable. And now derivative of x square is 2x and integration of minus cos x will be minus sin x. So this is minus sin x. Correct? So now plus sign. So alternate plus minus sign you can see now. Differentiation of this will be what? 2 and integration of this will be what? Tell me, integration of this minus sin x will be plus cos x. That's it, plus constant. So clearly this is the correct answer. Okay? So what is the technique? Understand. X raised to power n and sin x ka if you have to, or cos x. Cos x will also work in this manner. Okay? So what you need to do is, first of all, x raised to power n as it is and integral of sin x minus. Now differentiate this. Differentiate this x raised to power n. And you have to again one more time double integrate. Sin x integration is minus cos x. Again integrate. So this is going to give you minus sin x. Okay, and then minus के बाद plus. So basically plus minus plus alternate sign. X raised to power n. So let me just one more time tell you, huh? One more time let me give you. Okay, one more time. So it will be x square and then minus 2x and then plus 2. Okay, so what we did? Understood kya? Understood? What we did? X square kept as it is. Then we have differentiated with a negative sign. Again differentiated with a positive sign. Alternate sign will happen. Now integral of sin x. So ma'am minus cos x. Okay. Integration of minus cos x will be minus sin x. Integration of minus sin x will be cos x. I hope now this is clear. Huh? Is it clear now? Okay. So it will be done in like less than a few seconds. So finally this answer is absolutely matching. Okay. Alright. Chalo. Integral of log x. Integral of log x. Now, ma'am, log x ka integration, so we don't even know the formula. You have not taught us. So there is no formula for log x. Okay. So what we will do is we will apply by parts 1 and log x. Obviously, the second function is something which needs to be integrated, right? So second function will be this. And first function will be that should be differentiated. We don't know the integration of log x. We do not know, right? Okay. So that's why we have kept it as first function. Now tell me the formula. First function constant. Integration of second function. So integration of second is, integration of 1 is x minus integral of derivative of first function and integral of second function. That's it. Very easy. This is x log x. X cancel. So the integral of 1 will be what? Plus constant. All right. Okay. So now there is, although there is no formula, but I will highly recommend, if you want to be a topper, remember this. Integral of log x log x minus x. Okay. All the toppers will remember it. All the not so toppers, average student will be like, let's not remember it. ठीक है, निकाल लेंगे. We'll calculate it. Okay. Toppers know the importance of time. Even they have full faith. Yes, we can calculate, huh? But average students are like thoda sa chill pill. Toppers, x log x minus x is the integral of log x. Okay. Chal. Now there is one question from JEE Main 2019. Okay. No, it is part 1 of indefinite integration. Okay. Chalo. Let's do this question. X raised to power 5 e raised to power minus 4x cube. Okay. ठीक है. All right. Chal. So how to tackle this question? So basically this question is combination of substitution as well as by parts. Yes. So let's do one thing. Let's break it a little. So this is going to be integral of x raised to power 5. Okay. So what if I put e raised to power minus 4x cube? Okay, what I can do is this x cube can be kept side by side. Then we have x square e raised to power minus 4x cube dx. Can I do one thing? I can put minus 4x cube is equals to t. So that minus 12x square will become dx will become dt. So x square dx, x square dx, x square dx, right? X square dx will become what? Ma'am, dt by minus 12. So dt upon minus 12. Okay. Now this is e raised to power minus is put as t. So x cube from here will be minus t by 4. So minus t upon 4 integral. So finally we are having 1 upon 48 integral of t e raised to power t dt. Understood? So by substitution we have reduced the overall problem, but now we have to apply the by parts. By parts may you know that isolate may the last function would be, the second function will be this and first function will be algebraic function. The first function constant, integration of second function minus integral of derivative of first and integration of second, and that's it. So integration of e raised to power, so t e raised to power t minus e raised to power t plus constant. Now you put t right away. Now you put, okay, and let's not forget there is 1 by 48. So 1 by 48 already there. T e raised to power minus t. So minus 4x cube e raised to power minus 4x cube. Or we can do one thing now. We can just take something common. We can take e raised to power t common. So e raised to power minus 4x cube is common and we are having t minus 1, that is minus 4x cube minus 1. Okay. Alright. So now if I compare this and the right hand side. Let's compare this and the right hand side. Tell me 1 by 48 matching. E raised to power minus 4x cube matching. So fx will be option B, right? Fx will be clearly option B, right? Option B. Okay. All right. Clear. Option B, absolutely right. Okay, so this was asked in JEE Main 2019. So now these type of questions are popular, where what will they give you is, they will not say that integrate this. No. They will tell you, okay, integration of this is something like this and you just have to tell the value of fx. Okay. Alright. Clear? Chalo. Now next question. See again, in JEE Main 2020, similar type of question was asked. That, okay, integral of this is coming out as this. Now you have to identify a few functions. So ax and bx. So although you have to integrate it in a normal proper manner, but yes, they are giving you some hint also and they want to ask you some expressions. Okay. So how to integrate sine inverse square root x upon 1 plus x. See, whenever you see sine inverse now, what is the ninja tip of the day? Simplify and then integrate, right? So whenever you see inverse trigonometric functions, now obviously always think about substitution. Now the moment I am seeing 1 plus x, obviously my x should be substituted as tan square theta. Yes, x will be tan square theta. Okay, so if I put x equals to tan square theta, my dx will become what? 2 tan theta sec square theta d theta. Okay, let's solve. Okay. Sine inverse square root x is what? Tan square theta. And this is 1 plus tan square theta. And dx will be what? 2 tan theta sec square theta d theta. Okay. All right. Now this is tan theta upon sec theta. Tan upon sec. So sine inverse tan upon, this is sec theta. Correct? And this is going to be 2 tan theta sec square theta d theta. Tan theta is what? Tell me. So tan is sine by cos, sec is 1 by cos. So this is only sine theta. So actually this is becoming what? Theta. Sine inverse sine theta is what? Theta. Theta. 2 is also there. Tan theta is also there. Sec square theta is also there. And d theta. The moment you see now, this is actually a combination of algebra. Theta is what? Algebraic function. है ना? Don't think कि theta मतलब trigonometry. No. So basically, if you convert this in x, for example, to 2x tan x sec square x, then x is algebra or not. So again, Anushri was asking, ma'am, what will happen if both the functions are algebraic? No, that's the way it is. Two different worlds are there, trigonometry and algebra. When you have to make a product of it and then integrate, especially that time by parts is applicable. Algebra and trigonometry right away. Okay. Alright. So 2 theta tan theta sec square theta. Now, thoda sa it will be a trickier one. So obviously, trigonometry will be the second one. Okay. This will be the second one. Second. And this will be the first function. But you know that second function ka integration we should know. But do we even know the integration of sec theta, tan theta, sec theta? Or rather, let me just say tan theta sec square theta. Hai na? Do we know the integration of this? Tell me. Can anybody tell me the integration of this? Because second function ka integration I want to know. Second function ka integration I want to know. So yes, put tan theta is equals to t. So sec square theta d theta will be dt. So the finally integration of this will be tan square theta by 2. Because this will become t dt, na? So t square by 2 tan square theta by 2. That means, okay, first function and second function, if at all they are involved, so we know the derivative of both the functions definitely. Okay. Or one more thing, what we can do is, I can actually talk about 2. So 2 is already there. If 2 is there, na, then this is going to be tan square theta. Yes. Let's just make this 2 with 2 tan theta sec square theta d theta. Okay. Now, theta is your first function. This is your second function. So first function constant, integration of second function is tan square theta minus integral of derivative of first function. So theta ka derivative is 1 and integral of second is, you know, tan square theta. 2 is already there, na? That's why this 2 is compensated. Now that's it. So this is theta tan square theta is already there minus, now tan square theta ka integration we don't know. Tan square theta ka integration we don't know. So let me just write it as sec square theta minus 1 d theta. And now integrate. So integral of sec square theta, tell me. Integral of sec square theta is tan theta. So theta tan square theta minus tan theta plus 1 ka integration is theta and this is plus constant will be your answer. Now change it into x. Okay, ma'am. So tan square theta is obviously x. Okay, because you have substituted x is equals to tan square theta. So this is x minus this is root x. What about theta? See, if you have substituted x equals to tan square theta, so what is the value of theta? So ma'am, root x is equals to tan theta and theta will be equals to tan inverse root x. Okay, all right. So this is theta is tan inverse root x and plus tan inverse root x plus c. Correct? Okay. All right. Now what we want is, okay, So tan inverse root x. Tan inverse root x is already there. Hold on. So can I just club them together? Yes. So tan inverse root x, if I take common, it is going to become 1 plus x. And this is going to become minus root x plus constant. This is the final answer. Now tan inverse root x ke saath there is x plus 1. And the next to this function will be minus root x. So this is root x. So this is x plus 1 and this will be minus root x. So A function is x plus 1. That means these two are wrong. And B function is root x. So B function is minus root x. So option B is absolutely right. Yes, option B, absolutely right. Have a look and let me know. Okay. All right. All right. Now the last part of the today. So basically recurring model. है ना? तो by parts में there is one very important model that we have to do. That is your recurring model. This is your recurring model. ठीक है? This is your recurring model. Sec cube x. All right. Sec cube x. Now let us understand what is exactly recurring model. है ना? So to integrate this, we will do one thing. We will actually separate sec x and sec square x. Can we do that? Sec x and sec square x. Okay. So yes, sec x and sec square x integral. Now this sec square x can be written down as tan square minus 1. Sorry, tan square plus 1, right? So hold on. This is ROAR playlist, ROAR session. ठीक है? ROAR, if you go, there are 3 different playlists: ROAR physics, ROAR chemistry, and ROAR mathematics. Okay. Chalo, let's talk about this problem. Recurring model, sec cube x, right? Sec x, sec square x. Okay. So now we are going to apply by parts over here. In here, we are going to apply by parts. Now tell me one thing. Which one will you prefer as first function and which one will you prefer as second function? So obviously, there is one simple logic. That function whose integration is known to you, that will be your second function. We know the integration of sec x, by the way, right? Integration of sec x is known to you. So that's why this will be first and this will be your second function. Okay. So clearly, first function will remain constant. Integration of second function will be here, minus integral of differentiation of first function. So derivative of this will be 2 sec x tan x. Correct? So basically derivative of this. So 2 will come first, 2 sec x. Sec x ka derivation, sec x ka differentiation is sec x tan x. Understanding? So sec square x ka differentiation, how will you do? Tell me. Ma'am, 2 sec x. Then sec x ka again differentiation we have to do, sec x tan x. And so first function ka differentiation done. Second ka integration will be integral of sec x. Okay. Yes. Sorry, एक second ना. Second is this. Integration of second is this. Sorry. Second is this, right? First function is constants first and this is second. हाँ, so Jinal is asking, ma'am, both are trigonometry. Can we apply Eilert? Yes, both are trigonometry. We can still apply Eilert rule. Okay. So Eilert rule is applicable whenever if the problem is getting solved, Eilert rule is applicable. Okay. So yes, first and second. So first function constant, integration of sec square x minus integral of differentiation of first function. So differentiation of first function, hold on, I have made a mistake over here. So differentiation of first function will be what? Sec x tan x, है ना? And integration of this sec x, sec square x. Now it's perfect. Tell me. Yes, perfect. Sec x tan x, integral of sec square x. ठीक है? Integral of sec square x. Can anybody tell me what is the integral of sec square x? Integral of sec square x is known to us, right? Tan x minus integral of sec x tan x and one more tan x, right? Yes. And now, so this is basically, can I mark this the overall function as capital I? So capital I will be this, and integral of sec cube x will be this. Okay, so what we have done, let us understand from the very beginning. Sec cube x ka was given to us. I have broken down them in sec x and sec square x. Obviously, sec x integration we know, but sec square x integration, tell me, tan x. It is very simple. So that's why keeping it second function, because in the formula we have to integrate second and we have to differentiate first. So this is second, this is first. First function constant, integration of sec square x is tan x minus integral of differentiation of sec x is sec x tan x, and integral of sec square x is one more tan x. So that's why it is coming like this. Now, this is I is equals to sec x tan x minus, now what I will be doing is tan square x. Tell me, tan square x will be sec square x minus 1, yes or no? And now you multiply, I will be equals to sec x tan x minus integral of sec cube x dx minus plus integral of sec x dx. Can you see, again we started solving integral of sec cube x, but what has just happened? We have actually gotten the same thing over here. So this is also an I. I can write I in place of this. So I will be equals to sec x tan x minus I plus, this is sec x ka integration. So integration of sec x is log of mod of tan x plus sec x plus constant. Correct? Now just shift this I. 2I will be equals to sec x tan x plus log of mod of tan x plus sec x plus constant. I will be 2 will be gone and it is going to be 1 by 2. So this is the final answer. Understood or not? Let me know. Okay. This is how recurring integration will happen. So basically you start solving something and in between you are going to get the same thing. That will actually help you because you put I and the rest of the things will be very, very simpler. Okay. Alright. Have a look. Let me know if there is any doubt. Indefinite integration ka, if I talk about the weightage of indefinite integration, weightage is very less, but Without indefinite integration, Lakshmi, you just tell me, you are going to lose out on definite integration, which will at least give you 2 to 3 questions. That means 8 to 12 marks. Without indefinite integration, you are going to lose out on area under curve, 2 questions from that chapter. Differential equations, again 2 questions from that chapter. So overall integral calculus. Okay, if you miss out the basics of indefinite integration, then you are going to lose out on the overall integral calculus. You won't be able to understand definite integration, area and differential equation. These three are high weightage chapters. The choice is yours, Lakshmi. Although this is having low weightage, sometimes you get even one question, sometimes you don't even get one question. But yes, this without this chapter, you won't be able to do important chapters. Okay? Chalo. Now next question, which was asked in JEE Main 2019, है ना? Again from recurring integral cos of log x. So we need to figure out I is equals to cos of ln x dx. Correct? All right. So yes, you know that this is your first function and this will be obviously your second function, because if we take this as second function, then we should be knowing the integration of cos of log x. That we don't know, right? So yes, I will be equals to, tell me, first function constant, integration of second function will be x minus integral of derivative of first function. Cos ka derivative, tell me, ma'am, minus sign. So minus sign, the sign of log x. Log x ka derivative is 1 upon x. And then integration of second function. So integration of 1 is x. Directly let me write x. You know, x dx. X already getting cancelled out. And now I will be equals to x cos of log x plus integration of sine of log x. Can you see a similar type of question is this? Again, we have to apply by parts. So 1 multiply this. Obviously, this is first function and this will be second function. First function constant, that means sine of log x is constant. Integration of second will be x minus integral of derivative of first. Sine ka derivative is cos of log x upon log x ka derivative is 1 upon x. And now integration of second function is what? X dx. X cancel, and now can you see I equals to x cos x, x cos of log x. X is common, na? Then sine of log x, right? And this is minus I. So 2i is equals to, now understand, 2i equals to x is outside cos log x plus sine log x, and the 2 is gone, it is coming over here 1 by 2. Okay, so x by 2, cos log x plus sine log x plus c, option C is absolutely right. Okay. All right. See, Sanjay and Jeena. See, eyelet rule is basically to help you out to understand that which function cannot be integrated. So eyelet rule, that's why I told you, do not think about eyelet, because sometimes you might get confused. Now cos of log x, right? Although this is a trigonometric function. So yes. So yeah, but apply your brains. Understand in the formula of by parts, first function constant, integration of second minus integration of first ka derivative, integration of second, right? So integration of second, just tell me, out of 1 and cos of log x, do you know integration of cos of log x? No, you are calculating integration of cos of log x. So why do you want to make it as second function? It will make zero sense. That's why. Do not go for eyelet. Obviously, eyelet is parallel, but your brain should be working like this. Okay. So for simple functions, use eyelet. But for these type of functions, understand what are we trying. We are actually using this to calculate integration of very difficult functions whose integration is not known to us. Now, if I want cos of log x ka integration, so I am asking that, okay, it is very funny. Don't you find it funny? So, if some student is coming and telling me, ma'am, do you know integration, ma'am, how to find integration of cos of log x? And I am telling him, for that you have to tell me what is the integration of cos of log x. Don't you find it funny? Huh? To calculate something, I can't ask you the same thing, right? So that's why it is happening. Okay. All right. Clear? Chalo. Now, integration of the form e raised to power ax sin bx or e raised to power ax cos bx. Again, recurring integral will help over here. Okay. Recurring integral e raised to power ax sin bx. Okay. So, we have to mark it as first function and the second function. So, here again, this will be your second function. Why? Because you know the integration of e raised to power ax. Eilate rule के हिसाब से obviously second will be this will be first. है ना? Eilate TE. So trigonometry will be given the priority. Now apply by parts. First function constant. Sin bx kept as it is. Okay. So sin bx kept as it is. Integral of e raised to power ax will be what? Now, so sin bx first function constant, integral of second function minus derivative of first function. So derivative of sin bx will be what? Cos bx into b and integration of second function. Okay. So integration of this and this we need to place the value. So integration will be e raised to power x upon a. Right? E raised to power x up ax upon a. So this is done. Now again, can you see we are stuck in the same situation? The moment I start applying by parts, so this is how recurring integral works. If you are seeing since past 3 problems, this is what it is happening. We are trying to solve a problem, but again, we are getting stuck in the same problem, right? So again, we have to apply by parts and all. Obviously, this is your second and this is your first function. Again, let's apply the first function. Let's copy this. Okay. So this is as it is, minus b by a as it is. Now, first function constant, integral of e raised to power ax will be this, minus obviously it will be plus, and then integral of derivative of cos will be what? Minus sign, so that's why it is plus, and integral of e raised to power ax will be e raised to power ax upon a. Okay. Now, if you observe, we actually started with this. This is your u. This is your u. So, this is what your u is. This is what your u is. This is what your u is. Ravi is asking why b by a. Hold on. B by a is coming because if you differentiate the first function, that means sin bx ka derivative will be what? Cos bx into b. And if you integrate the second function, e raised to power ax ka integration will be e raised to power ax upon a. That's why this minus b by a is coming. Okay. Alright. Now mark it as u, and if you solve it, your u will directly come out as, yes, so the final result will be this. Let me just tell you. The final result will be this. Are you getting it? How am I getting? Okay. Let me do it. Okay. E raised to power ax. E raised to power ax sin bx. Let's do it. Okay. Integral dx. This is your second function. This is your first. First function constant. This, let me take it as I. First function constant, integral of second function. So, integral of second function will be what? Tell me. E raised to power ax upon a minus integral of derivative of first function cos bx into b, and integral of this will be e raised to power ax upon a dx. Correct? Okay. I will be equals to sin bx e की power ax upon a minus b upon a, and we are having again e की power x cos bx dx. Correct? Now again, this is your second function, this is your first function. I will be equals to e raised to power ax upon a sin bx minus b upon a. First function is constant. Integration of this is this minus integral of first का derivative. So cos का derivative is minus sin bx, and b is also there, and this is e raised to power ax by a dx. Can you see this? I equals to, this is e की power ax upon a sin bx minus b by a square cos bx e की power ax, correct? And we are having minus. So negative of, this is b square by a square, and this is actually your I. E raised to power ax sin bx is your I. Now push it. I 1 plus b square by a square. This is going to be e raised to power ax sin bx upon a minus b by a square cos bx e की power ax. Right? Plus constant. Correct. Yes. If you take LCM, what will you get? If you take LCM, so it is going to be I, and if you take LCM, a square, a multiply a square plus b square upon a square. Also take LCM over here. So e की power ax a sin bx minus e की power ax b cos bx upon a square. A square cancel. So I will be equals to a square plus b square, e की power ax taken common, a sin bx minus b cos bx. Yes? Yes, by parts twice we are doing. Okay, it's a little bit lengthy process, but if you just see, it is actually not very difficult, huh? This we are doing, this we are doing, this we are doing. But if you see, if somebody comes, exactly, Anshuman, yes, that's what I'm saying. That's what I'm saying. If somebody comes in between, and if he or she will observe this particular thing, he'll be like, okay, no way, I'm not gonna do this integration. I'm gonna leave this integration. But if you are with me since the very beginning, na, then it will not look dangerous. Now just let me tell you one thing. That I will give you two important formulas, because I don't want you to waste time in calculating this, right? So just allow me to give you a direct formula for this, okay? E raised to power ax sin bx or e raised to power ax cos bx, okay? So understand, e raised to power ax will be there. Denominator mein there will be a square b square, a square plus b square, correct? Okay, this is sorted. And now in the bracket you have to differentiate this. So ax ka derivative is a and copy sin bx. Okay, perfect. And after that minus sign, now you just, minus sign is there, now you just have to differentiate this basically. Or what you can do is, you have to apply plus sign and then, yeah, so minus sign and differentiate. This is fine. Okay, same thing, e raised to power ax a square b square. Now this is a, है ना, e raised to power a. Copy paste cos bx, copy paste, plus is not there, minus is there, understand, minus, and you have to differentiate. So derivative of cos is minus sign, so differentiation, okay, and sin bx and one more b will be there. Okay, chalo, okay, let's do one question. Let's apply the formula right here. So e raised to power 2x upon 2 square plus 1 square, bracket applied. Then we are having, ma'am, differentiate this. So 2 cos x copy pasted minus. This time you just have to differentiate cos x. So derivative of cos x is minus sin x. So that's why there is a plus sign. That's it. Plus constant. Easy peasy kya? Easy peasy. Final answer will be, tell me. So it is going to be e raised to power 2x by 5. That's it. Done, done, done. Done, done, done. Give me a big thumbs up if you have done this. If you are done with this. Okay? So this is what last question is. This is what we are ending this. Okay? And also one thing I would like to tell you guys regarding this biggest scholarship test. Okay? Biggest scholarship test, you can clearly see MVSAT. Okay? So MVSAT, you can just note down the dates. This is absolutely free, you can see. Okay? So offline test you can give on your nearest centers. Dates are here, but I too will suggest give offline test. But if by any chance you're not able to give offline test, go for online test for sure. Okay? Meet some people, go out, have fun, and do the test, and then let's see what happens. Okay? All right. Yes. So this was the last question. Now, next we have a lot of things. So at one go, indefinite integration might be a little overwhelming. So if I take one shot, you'll be like, oh, something is happening. So now I would highly recommend that just get your basics very strong. After that, because after this point now, indefinite integration will be a little bit tougher. Yes. So like 3-4 days, just make it strong. I will be taking indefinite integration part 2 on Thursday. Before that, I cannot take, because Monday, Tuesday, Wednesday, Shreyas sir and Nabamita ma'am has their own slots. Okay. All right. That Gina, this is for the shortcut is applicable only for first derivative. Now you just have to apply the quotient rule. है ना? Implicit function में apply the quotient rule. Quotient rule, you know, the double derivative mein you have to apply the quotient rule. Okay. All right. I guess we are done. This is me, Namrata.